Hi, welcome back to a follow-up to this interface conversation we've had. What is it? It was probably 3 weeks ago now. Since this was first discussed, I wrote a version in PB that cobbles together the logic, and it's in this thread here actually. But I don't really want to go over that again. There's a video about that already, so let's look at something new. Here I've cobbled this into the math test because it's got the dialogue stuff in it. Not that I'm using it for this example anyway, but I can do a bunch of different tests from the one front end without doing much work to patch it all together. But here we actually have the library up and running, and it's hard to probably work out from the PB code, but we're creating a string with the DLLs we want to open. We're calling the function to open this string, open the DLLs individually, and it returns a pointer to the structures. In this case, it's like an array pretty much. So I can go through these and get some basic feedback about it. And here we've actually got an instance where we're running through the functions in the interface, and we're adding them to the list. Oh, sorry. We're up here. This is actually occurring up here. I've already added some functions above this. I've got some more test code here, testing whether the addition works, that kind of stuff. So I can add a command set by name, and I can attach functions to that name. So they can be sort of this tiered approach, you know. To visualize what I'm talking about, we have sort of our command set, you know, the name of our command set here, and then below that as branches we have, you know, function 1. It has a real name, but you know, whatever this thing is doing, etc., etc. This kind of structure. It's running through and opening up the command set, getting the functions or requesting the functions and putting them into its global global database really, and so we can look them up later on. At the moment, it does the opening, it does the requesting, it creates the command sets by name, and then appends the functions that are exported to that command set. And we'll have a look at the output. Apologise for this ramble. So we're using the Math64 library as the thing. I've got a couple of different tests banked into here. As I said before, it's just easy to throw them all in the one thing. So we'll test the interface, and the part of the output here we're concerned about is this section here. So it's running through and telling us what command sets have been added, and I did a loop and added command sets named test 0 through to 10, and I had appended some pretend functions to this test number 5, 100 of them. Internally, the public function library has a kind of stack where we append new command sets by name. Then each one of those can have its own stack of these functions, and then this expands as it grows, as it needs to. So here I'm just testing to see if we can have a bunch of functions added to it without it dying. The one at the very bottom is the one we really care about. This is actually doing exactly what we expect. This is initialized internally. It's loading the DLL. It's getting the initialization command set stuff out of it. It's asking how many functions do you want to publicly declare, and then running through, and it's making this command set name, we'll just call it test banks, and adding 2 functions. It's a lot of messing around for something that seems so simple. Now, the alternate to doing it by name is that you would have, I'll put this in PB terms, you would have like a structure or a list of constants, you know. You might have, you know, you might name them like this is a banks, and this is the create create bank instruction. This is the auto counter feature, by the way. So this starts at 0, and then we're telling it to add 1 to auto counter after it's returned the result. So a bunch of constant definitions would be like, you know, delete bank or something. Resign as bank. Whatever, you know, get free bank. So you have these include files that have all of these definitions of what these external functions are going to be, and there's a whole bunch of this stuff. If you need to use a bunch of different command sets, but only want to use the odd command here or the odd function from this one here, you kind of have to include all of it, not just a part of it. That's why I want to use a naming system. So you can just declare the name you want to refer to, and it works out whether it exists or not. If it doesn't, it's going to crash. So here is our get public function from within this test DLL, and it works pretty much the way I just describing the other day. I've used the select case. Now I could store this in an array, but really when I looked at it, I went, well, I'm just going to be initializing this, dumping it into a structure of pointers to the strings and have pointers to my functions. This is pretty much as annoying as what that is doing. So I'm just happy enough to use this. There's one difference though, is that we have one instruction in these lists here. So we can store alternate command sets. So here we've got the banks commands, our mock-up banks commands anyway. So if we add a third case here, they have to be linear at the moment. But let's say we had file system. Delete that. Grab one of these. This has to be the one following this. What happens is when this is queried, we're getting this instruction. The phraser is going, okay, you want to add command set, and the command set called banks, or test banks in this case. Then everything after that is appended to that command set till we hit the next add command set, file system. Well, we'll just call it delete file or something. I've got a pointer here to a function that doesn't do anything at either actually, so it doesn't really matter. So I just build that in the background, flick back to PlayBASIC, get rid of this. And when we run it in debug mode this time and test our interface, go back to interface, we've got our test banks with our two functions attached to it, and we've also got our file system, I think I'll call it system, with one function attached to it. So that's actually working. So we can have one DLL that includes many command sets. So we might just have, you know, one DLL that includes, you know, 5 or 10 of them to make it easier to write, and then have an exposed interface that allows other parts of the command set to access back into it if they need to. And these things can be functions that are, you know, for public use or for sort of low-end, back-end use. Sometimes it's handy to have both, which is one of the problems with the approach for doing the OpenGL library, you know, a bunch of years ago, and trying to have this swappable interface. You kept running into situations where you needed to access the device without having any sort of direct communication with it. It was solvable, but it was just ugly. You know, I'm trying to make it less ugly to write. You know, if it's easier to write and it's easier to write for, and we give the information out there to people and say, here you go. You can either use, you know, PB to DLL in the future, which will export this basic data as it's needed, or roll it yourself. This actually does what we want it to do. And there will be another function that will resolve external functions or something, or resolve external, I don't know, solve, whatever it's going to be. It'll be pretty much the same structure. You run through here, you'll have the command set name and the function you want to find, and the location where this function pointer is meant to be written into, and that'll be it. The actual code itself is pretty ugly. Like, you've got, I don't know how many lines this has turned out to be, but it's just straight C. It's not anything special. So all we're using here is a bunch of structures, managing the memory ourselves. We're adding a function. The linking I quite like for the buffers here. So we add new functions to an existing command set. Each block has a predefined chunk. Where is it? Here. This thing here. So we have a number of strings that can be in one section. And then once that's full, we allocate a new string chunk and link it to the end of this. So we can still have lots and lots of banks, but we don't have to allocate a big chunk of memory up front. We can just kind of allocate as we need them. And this avoids having this constant allocation problem. If we knew the number of the number of functions up front, we could do one allocation that solves the whole problem. But I just figure that having to always keep track of the number of functions you're exporting and importing all the time is probably going to get tiring. A lot of this is kind of, it's tedious work. It's just garbage. This is the loader function. This will be part of the runtime. So we're just passing a string in, the length of the string. We're mapping where the commas are pretty much to make sure we're splitting it into commas. In the actual VM, we'll do a bit of extra work in this to make sure that we're loading stuff from where are we here? We're this load library, for example, which is loading the DLL. We won't be using this. We'll be using the internal VM version of this, and that actually handles it works out whether the DLL is being loaded from disk or being loaded from an internal bound resource for you. You just call a function and it does that job for you. So these are sort of interchangeable with the system ones. Same with the get proc address function. Just hard coded in, didn't care. Any DLL that has PB command sets will have this structure in it. If it has that in it, okay, we've got functions, we need to phrase them. If it doesn't, we don't care. The logic here is pretty much the same. We check to see if our get public function exists. If it does, we set our pointer. This is a function pointer, remember? This is a pointer to a piece of code we're about to call. So we have to be kind of careful we don't call something we shouldn't be. And then we just loop through, passing this function our index and our structure to fill out. We just check that we have a name returned. If not, it breaks. So when we've reached the end of the table, we're done. Because in here it doesn't care. It doesn't care. It's just going, okay, these are all function pointers. Let me add them. It's all going to be good. What are we doing there? Oh yeah, we're just checking to see if this thing returns something. This thing returned a pointer to a string. Finding the end of the string. It's null termed. Just checking to see if this string is in the header. If it is, we just go, okay, that must be a add command set. The name's going to be following that. So it's pretty ugly. It's pretty sort of logical. It's just straight C. We just, at the end of the load process, we return the load libraries. We need this data for later on. So this will handle the loading of all the libraries up front. Yeah. So this will load all the libraries we want to load by name. And then when we close the runtime down, we need to go back through and close these libraries. Clean up after ourselves. We haven't bothered to write that process yet. There you go. So this thing actually works. So it has to be patched in, to the runtime process, as per most things. But the actual work, the grunty work of it, is up and running. So hopefully the next little thing is to make sure we're getting our external functions working properly and get it working in the test bed. And then once once I'm happy with it, I'll publish it. I'll try and drag the whole code base into the runtime. I find it's easier to write things separate from the runtimes because they're big projects. It's not small, and it's easy to get lost in what's happening. Even the current revisions of the runtime, you still got there's the updated runtime, and there's a public interface for when DLLs from PB to DLL talk back to it. A lot of that stuff is not needed anymore, or it'll have to be replaced at some point actually to get this DLL processing stuff to work for PB to DLL I'm talking about. So there's a lot of code in it that probably doesn't need to be there. We're going to have to shuffle up the command sets, which means another big, hackathon pretty much. In some regards, I'm tempted just to replace one or two command sets, make them external, and go, okay, is this working okay? Because I know if we go hell for leather with this stuff, it's going to just be like a house of cards. Once you pull one thing, it's all going to collapse. Yeah. So that's why I like to do it separate from here. And this test bed example here, it's got a bunch of stuff attached to it. It's got the why is this all before actually? Where do I run it here again? So for console, you can do test the banks library, which is another DLL that's attached to the side of it. So we're just doing a test of the updated bank commands, which started out as an alternate way of doing indexes, which I think it's a better solution. Well, sorry, it is a better solution than what we had before. But I can see some situations where existing bits of PB code that rely upon get free whatever, get free, may actually behave differently. Where people might have expected, if I allocate a new sprite, for example, I do this 10 times and I free them, I get the same set back. In the newer solution, that may not actually happen. You might get different set of indexes than you're expecting. So code that relies upon the index being within a certain range or something like that may find it doesn't work. And what we're bound to find is some old example somewhere will do something weird. Every time you change the stuff, someone goes, hey, my program from 10 years ago doesn't work. And you go, oh, okay, great. What about it doesn't work? You have to try and sift out, is it not working because the command set's broken, or is it not working because it has an expectation of the command set working a predefined way? 50-50. Like, for example, some of the old examples rely upon sprites not having error detection, because old versions of PB didn't have runtime error detection in them. They couldn't pick them up. So if you find those old examples, and you find the old examples, and they would have things like this in it. I'll just do a quick little one. Sorry, draw a sprite. If I run this in PB today, we should get didn't get an error though, did we? I wonder if draw has that on it. Has error detection on it. It may not. Position, sprite, SPR, 100, 200 plus sprite times 2. Okay, so that command does do that, but the draw sprite doesn't seem to produce an error. I mean, there's one example there, right there, where this error detection, if you don't notice that something doesn't exist when you try and modify it or try and display it, in the case of a sprite, then things will, stop. Runtime will stop you, and in old examples, this would actually, in old versions of PB, this would run perfectly. It didn't care if the sprite didn't exist. This function didn't do anything. So it was basically letting you get away with it, So you have to go back through those old programs and wrap them up in tests to make sure the sprites they're using exist. So if I run this one now, it'll be fine. We just run straight through and out the other end. Nothing's happened. My point with that is that, behaviors of the runtime have changed over time, and there are bits and pieces, like I can think of some parts of command set, like some range things have changed over time. I can't think of what it is now. The shape command sets, for example, they used to have inclusive ranges. I never liked that. I'm not a fan of this. For example, if you go dim table 10, this is a common little basic thing. We've actually got 11 cells because we've got all of these cells here. If I just go table 0, 1, 2, 3, 5, 6, 7, 8. We can prove this. So we've actually got 11 cells. We've got from 0 through to 10. So the range is inclusive. The screen, for example, is not. Pixel 0 is the one on the left-hand edge of this screen, but the width of your screen is actually not a pixel. It's actually the start of the next row. So it's inclusive, exclusive. So if I run this one here, this will run fine. Of course, if I try and display something that the next cell, index 11, we'll get an error. Now, I've always preferred that if I declare something as having 10 cells or 11, that it does this. We would get a range from 0 up to that value I set. So when you have a table size of 1, you have index 0. But in BASIC, it's kind of a common convention. Anyway, got sidetracked here. Thanks for watching, and we'll see you next time. Hopefully this thing will be up and running within the next day or two, next session or so. We can start patching this thing together and make it a real Frankenstein. Won't that be fun? Thanks. See you later.